Hey guys, and welcome to Unsupervised Deep Learning in Python, Part 4. This course is the next logical step in my deep learning and machine learning series. I've done a lot of courses about deep learning, and I just released a course about unsupervised learning, where I talked about clustering and density estimation. So what do you get when you put these two things together? You get unsupervised deep learning. In this course, we'll start with some very basic stuff, principal components analysis, and a popular nonlinear dimensionality reduction technique known as t-SNE. Next, we'll look at a special type of unsupervised neural network called the autoencoder. After describing how an autoencoder works, I'll show you how you can link a bunch of them together to form a deep stack of autoencoders that leads to better performance of a supervised deep neural network. Last, we'll look at restricted Boltzmann machines. These are yet another popular unsupervised neural network that you can use in the same way as autoencoders to pre-train your supervised deep neural network. I'll show you an interesting way of training restricted Boltzmann machines known as Gibbs sampling or contrastive divergence. And I'll demonstrate how, even though this method is only a rough approximation, it still ends up reducing other cost functions, such as the one we use for autoencoders. Finally, we'll bring these concepts together, and I'll show you visually what happens when you use PCA and t-SNE on the features that the autoencoders and RBMs have learned. And we'll see that, even without labels, the results suggest that a pattern has been found.